In this video, we're going to do another projectile motion problem, but one that's a little bit more difficult. So in this one, it says a cannon shoots a cannonball at an angle of 60 degrees with respect to the horizontal, and a second cannon shoots a cannonball at an angle of 30 degrees. Show that the cannonball that's fired at 60 degrees reaches a maximum height 3 times that of the cannonball fired at 30 degrees. So they didn't give you any numbers to plug in. What they want to know is, can you answer questions without plugging and chugging numbers? This is a fundamental skill that one needs to develop. So what we're going to do is we're going to draw my cannonball, and I know that I fire that cannon with some speed v0. And this will be my y-axis. This will be my x-axis. Cannonball will go up to some height right here. That height will be y in this case, and so we'll call that h, and that will occur at some time. So it'll occur at some, and I'm going to call that time t min for t max. Okay. I don't really care about the distance here, although I know because it's a symmetric problem that it will take half the distance that it goes all the way across, and it will take half the time that the ball was in flight. But even if it was not symmetric, I'm going to work the problem in the most general way. And this is theta. And so I'm going to write some things that I know down. x0 is 0 meters in my problem. X I'm going to call equal to r, the range, and I don't know what that is in the long term. But mostly what I'm interested in this problem is knowing about Vx0 and Vy0. Vx0 is V0 times the cosine of theta, and I know that because I can see that there's a little triangle here, and that x component is in this direction, which is the adjacent side. Vy0 is V0 sine theta. Ax in our problem is 0, and Ay in our problem is minus g. What I want to do is I want to write the 4 equations for projectile problems. One which says x is equal to x0, but that's going to be 0, plus Vx0. But I'm going to replace Vx0 with this, V0 cosine theta. V0 cosine theta times time plus 1/2 axt squared, but that's 0. I'm also going to note that I have a y equation here. Y is equal to y0, also set at 0, plus Vy0, V0 sine theta times time plus, and I have this minus g, 1/2 minus g t squared. And I want to look at that for a minute here. That height could go down to 0, but right now it's at some height h that I don't know, and I want to solve this equation for the time it takes to get to the maximum height. So when is that? Well, it turns out I know it, and I could write it very quickly because I happen to know a lot of things about this, but I want to look at it in general as a way of attacking these problems. So in general, this is a problem that is second order. Okay? It is a quadratic equation. And I'm going to want to write that then in the following manner. I'm going to want to write minus g over 2 t squared plus V0 sine theta times t, and we'll bring that y to the other side, plus minus y is equal to 0. This is to find the coefficient a, this the coefficient b, and this is the coefficient c. And there's a way of solving equations, their second order, which you should know from algebra class, called the quadratic formula, that says when you have a quadratic equation with these coefficients here, a, b, and c, the solution for that is t equal minus b plus or minus the square root of b squared minus 4ac, all of that divided by 2a. And what that does is that if you plotted a different graph than the one we have, if you plotted a graph that involved t versus y, the time in which you reach any point, let's say this value of y here, that value of y that was in this graph would be given by this time and this time here, and we could find that by solving this equation. Now, for that particular thing, you see there's 2 times, and the reason there'd be 2 times is there would be this term out here, and then there would be plus or minus the square roots, and when one of them would be correspond to the plus, and the other would correspond when you subtract it. At the maximum, right here, y max, which we'll call h, the line only touches the curve once. So you can only get one answer. The only way you can get one answer here is if you add and subtract something that doesn't change it, which means b squared minus 4ac has to equal 0. So that's what it tells me. This must be 0 when you reach a maximum height. So for t max, is minus b over 2a. So this works in general, and if that's 0, you get the point, the time at which you reach the maximum height. What if this is negative? If it's negative, then you're attempting to fit a curve to a height like this where it never reaches. And the square root of a negative number gets you an imaginary, which means that you have complex times which do not exist in the real world. So if this is negative, you're up here and it never reaches, so there is no time solution to your problem. If this is a positive number, b squared minus 4ac, then you're down here somewhere. And if you have it 0, then you've hit it at only one point, and that point happens to be at the time where you're at max. So this would be t max. Well, I've got everything I need because I've got right up here b and a. So I have minus v naught sine theta, and all of that's divided by minus g over 2, but I've already got a 2 here, so minus g. So a g goes there, and that becomes not a minus anymore. Now I can find the height. Y is equal, so y max I should say, which is h, is equal to v naught sine theta, right back up here in this equation, times t, but there's t, v naught sine theta over g, minus g over 2 times t, which has got to be squared. Alright, so the height, this is v naught squared sine theta over g. Here I got v naught squared sine squared theta. Oops, I lost a sign here. V naught squared sine squared theta. And I have a g divided by g squared, which puts me one more g down here, plus I have a half. So V naught squared sine squared theta over 2g. Let's check the units. Meters per second, and I square it. So I got meter squared per second squared. Sine has no units. I'm dividing that by meters per second squared. That cancels. That cancels 1, and I'm left in units of meters. Good. Checks out. If I have no gravity, then the height could be infinite. Well, that's because it would never come down. If I had no speed, then I would never get to any height. If theta is 0, if I shoot it horizontally, then the sine of 0 is 0, and I get no height. If I put in theta of 90 degrees, this is 1, I get v squared over 2g. This is a straight free fall type problem. Check your work and see if it makes sense. This formula is true for any angle because I didn't derive it for any special angle. So if I want to compare two different angles, all I have to do is take the ratio of two values. So I'm going to look at how does h of 60 look versus h of 30. Well, let's see, that would be v naught squared sine squared of 60 degrees divided by 2g. And then I will divide that by v naught squared sine squared of 30 over 2g. The 2g's cancel, the v naught squares cancel, so there's no need to know anything about the speed of the projectile as long as it's not 0. If it's the same, it doesn't matter. Notice the gravity, as long as there's gravity, it doesn't matter if this is done on the moon or on Earth, you get the same answer. It all cancels out. And you simply get the sine of 60 over the sine of 30 squared. Well, that says h60, h30 is the square root of 3 over 2 over 1/2 squared. Well, it kills the half. Square root of 3 squared is 3. So h60 is 3 times the height of the cannonball shot at 30 degrees. You don't see things like it doesn't matter how fast it's shot. It doesn't matter what gravity is shot. It doesn't matter if it's shot in the moon. You don't get that if you're plugging numbers in. This is the way people really do work. And this is what you have to be able to do in college work. So make sure that you practice this. These are the harder things to do. Make sure that you have mastered your algebraic skills. All right. I will do part B in the next video.